look at it now. Right, so the likelihood ratio is when a question asks you to find how likely is it that this thing will happen. And when they say something like that, they're talking versus it not happening, all right? So it could be that it is a risk question. What is the relative risk of something happening? Relative risk is found as a particular sort of likelihood ratio, okay? So we're going to have a look at a relative risk question first. So let's have a look. I just made one up. Guess what about? So we've done a little survey of students in school, and we found out that 56 of the people who have reported with COVID have had the vaccine, 892 people with the vaccine have not had COVID, 84 people that have had COVID have not had the vaccine, and 212 of the people who haven't had COVID have not had the vaccine. So we've got this table. First thing we always do with tables, total them up. So we want all the totals, even though we may not be interested in them all. So we've got 948, 296, 140, 1104. We use these to check that we've got the right amount, but I use my calculator, so I'm pretty confident that this is the total. All right, so the sort of question that they could be asking here is, what is the relative risk of having COVID if you've had the vaccine versus not had the vaccine? Okay, so question, what is the relative risk which we often call the RR of and they'll use all sorts of words here, like opposed to, or the common question in this particular one is they claim that it is 10 times less likely for you to have COVID if you've been vaccinated than if you haven't been vaccinated. Determine whether their claim is correct from the current data, or one of those sorts of questions, so you can be actually answering it. And then they might have a, why do you think this could be incorrect, or something like that. So there's often a place for you to actually offer some information based around your own knowledge, and it could be things like who did they ask? Did they ask this information in a wealthy suburb, or did they ask this information in a wealthy country, or whatever that you wanted to say? So it's sort of putting doubt on whether it's accurate or not. All right, so the good thing about this is you've now learnt about conditional probability, and these are actually conditional probabilities. So last year when we looked at this, we would have said, what is the probability of COVID if vaccinated, right? But now we know that is the probability of C given V, all right? So we know what we're talking about now is conditional probability. So that equals 56 over 948, all right? Having COVID, given they're vaccinated. So we're only interested in this line, 56 over this. The probability of COVID given not vaccinated, we've got 84 over 296. So the conditional probabilities of these now make a little bit more sense, all right? So therefore, if we are looking at the relative risk of vaccinated versus not vaccinated, remember it's not a probability because it can be over 1. This is the one time you're finding something that can be over 1. Equals whatever you're looking at versus what you're not looking at. So 56 over, it's a ratio. So therefore we are dividing them. So relative risk ratio, a likelihood ratio. which also helps you to understand you're comparing a fraction with a fraction. So what does that equal? You put it in your calculator and it gives us 0.2 approximately. Now, what does that 0.2 mean? Anybody? So we turn it into a percentage because a percentage makes more sense to us. 20% more or less likely? Right, so 1 is the same ratio. 1 means there is no difference between them. If we're less than 1, it's a less likely. If it's greater than 1, it's a more likely. All right, so 20% less likely to have had COVID, have had COVID if vaccinated versus not vaccinated. All right, perfectly made up numbers. Have no idea. I probably could have looked them up on the online somewhere. But what I now want to have a look at is where it's a likelihood ratio. All right, so here's another table. Read books or read anything. Don't read much, anything, whatever. People will ask, do they read or do they not read? Their answers were either a yes or a no, not a maybe or a sometimes. They'd put themselves in one pool or the other. Do they catch a bus to work? Very related to whether you read or not. Work, school, whatever we've got on with work. It's collected this information, 32, 15, 110, 96, added it all up. And got 142, 111, 47, 206, and a total of 253, which we don't really use in this particular case, except for checking that we add properly. Okay, so the question is, how much somebody's really interested in this. You know, there's lots of people that are really interested in strange things in the world. So somebody's really interested in whether people who read might be more likely to catch a bus to work than not. They're going to say it's twice as likely. So the statement is twice as likely to catch a bus if you read than if you don't. Okay, that's interesting. Okay, it's very interesting. This person's done this huge big study. They've got a masterate or maybe even a doctorate in catching buses and for reading. You know, it's a limited amount of things you can get a doctorate in these days. So here they've gone and done all of this really incredible stuff, and they're doing their mathematics on it. They've got this thing here, and they're going to do this likelihood ratio. Relative risk, likelihood ratio. So we're going to find the likelihood ratio of reading, bus to work given reading, and bus to work given they don't read. So bus to work given they read, bus to work given they read going this way equals 32 over 142 and 15 over 111. All right, so we want the likelihood ratio of, I've just shortened that to LR, I don't know if it's a thing or not, but I know what I'm talking about, of reading versus not reading. And again, double-decker fraction, 32 over 142 compared to 15 over 111. Put it in our calculator, and we get 1.67 rounded. What does that tell us?
I'm going to put in that's not correct. It's less than twice as likely as 1.67 times.
Good. To be twice as likely, that number would need to be 2. It's less than that number, so the claim is not correct. It's not twice as likely. It's 167% likely, so approximately 1.45 times as likely. Well, 1.67 times as likely, right? 1.67 times as likely. So no to the claim. And it might say something random like, why might it be that there are more people who read catching buses than people who don't read? And your answer might be something like, a bus is a good place to read, right? It's highly likely that if they're not reading a book on the bus, if it's given the bus might be a bit long, they're probably playing on their phone. They don't sit and talk to the person next to them, although some people do, which is a really nice thing to do.